Lesson 4.3 on the least common multiple. All right, we talked about the greatest common factor in the previous section. In this section, we're going to talk about the least common multiple. A lot of students get those too confused, so we're going to do our best to make sure you understand which one is which. We'll start with the definition. A multiple of a whole number is the product of that number and any natural number. So if you have a whole number like 10 and you want multiples of 10, you multiply 10 times 1, 10, 10 times 2, 20, 10 times 3, 30, 10 times 4, 40. Those are multiples of 10, 10, 20, 30, 40, 50, and so on. All right, if you have a couple of numbers, we'll talk about multiples being shared. A multiple that is shared by two or more numbers is called a common multiple. And the smallest of any common multiple of two or more numbers is what we call the least common multiple, or the LCM. That's kind of like the least common denominator. I'll talk about that in just a little bit. But right now we're just going to call it the least common multiple. And I'm going to show you two ways that you can find the least common multiple. If the numbers are not too big, you can probably do these in your head. But I'll show you both just in case you need a method to use. To find the least common multiple of 8 and 12, one way you could do it is take the numbers and write multiples. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5. And we just keep on doing this until we think we've got enough of these. Okay? 12, multiples of 12. 12 times 1, 12 times 2, 12 times 3, and so on. I can already stop because I matched right here. This one matched this one. There's no number smaller than 24 that's in both lists of multiples. So my least common multiple here, least common multiple is 24. That's one way to do it. Another way to do it is to use prime factorization. So I'm going to write the prime factorizations for 8. That's 4 times 2, and of course that's 2 times 2. So 8 is 2 to the third. And 12 is 2 times 6, and 6 is 2 times 3. So 12 is, there are two factors, 2 to the second times 3. Now what you do is you list all the different factors, whether they're common or not, and that's 2 and 3. There are no other prime number factors of 8 or 12 other than 2 or 3. And then you look to see how many times each of these factors are used. And you take the most times it's used, not the total. You don't add. You take the greater amount. So in this case, there are 2 2s, there are 3 2s, so 3 is greater. Here I have 1 3. I don't have any 3s here, so one of those. And 2 to the third, remember, is 2 times 2 times 2. That's 8, so this is 8 times 3, or 24. And either way I do it, you can see I have the same least common multiple. I actually kind of prefer the first method because I can kind of keep track of the numbers in my head. Even if the numbers get to be a little bit bigger, if you're careful and you practice this, you can get good at it. Now here's one where the numbers are double digits and they want the least common multiple, not the greatest common factor. The greatest common factor here is the biggest number that divides evenly into both. That's 8. I want the least common multiple. The least common multiple will be at least as big as the bigger of the two numbers. But in this case, my least common multiple is not 24. 16 doesn't go in 24. If it helps, 16, 32, 48, 64, 24, 48. There's my guy. Oh, there's my guy, 48. That's my least common multiple. Here, with 20 and 25, I'm thinking 100. 20 divides into 100 5 times. 25 divides into 100 4 times. This is a multiple of both 20 and 25. Way over here at the end, it's a little trickier because you've got these two kind of small numbers and then one that's a little bit bigger. So if we start looking at multiples here, what I do is I look to see multiples of the the largest one in this case, and I look to see if they divide into that. So 20 times 1, well, these don't divide into that. 20 times 2 is 40. That goes into it, but not that. 20 times 3 is 60. That goes into it, but not that. 20 times 4 is 80. That goes into it, but not that. 20 times 5 is 100. Neither one of those divide evenly into 100. But here's the one. 20 times 6 is 120. 120 is a multiple of 6. 8 is a multiple, 120 is a multiple of 8, and 120 is a multiple of 20. 6 times 20, 8 times 15, and 20 times 6. And that would be my least common multiple. Let's try this now with monomials. Let's find the least common multiple of the monomials. Now remember, monomials are numbers, variables, or products of numbers and one or more variables. So we start with the number parts of the monomials called the coefficients. These are the coefficients. And we find the least common multiple first, starting with the coefficients. Well, I look at 6 and I look at 44, and if I start listing these out, these are going to take a while. So I'll do a quick 6 is 2 times 3. 44 is 4 times 11, which is 2 times 2. So this is 2 times 3. This is 2 squared times 11. They have a 2, a 3, and an 11, and they have two 2's. 1, 3, and 1, 11, 2, 2. So this is 4 times 3, 12 times 11, 132. So I have 132 for the least common multiple of the 6 and the 44. Then I have D's, the variable D. This is the variable D over here. The variable, I have 2 factors here. I have 3 factors here. All right, so I'm going to have D that's common, but how many? Well, I'm not looking for exactly what they share. I'm looking for the greater amount. And I have 3 here, which is greater than 2. Look at the exponents. So it's the greater amount that I need, and this would be my least common multiple. Let me try that again with part B here. I have 9, and I have 15. For 9 and 15, I'm thinking 90. 9 goes in 10 times, 15 goes in 6 times. 90 is a multiple of both 9 and 15. It's the smallest one that I can think of. Nope, I just thought of a better one. So I almost heard you tell me. It's 45. 45 is even better. I had 90 in my head, but 45 is even better. Be careful so you don't make a silly mistake like I just did. I have x's, I have y's. I have x's, I have y's. I have 1x here, I have 2x's here. So 2 is the most. I have 2 y's here, I have 1 y here, so 2 is the most. That's all my variables. I have it. That would be my least common multiple. Now over here, with a 4 and a 15, I believe 4 and 15, that would be 60. 60 would be my least common multiple of those two numbers. I have g's and I have h's. So I'll put a g here and I'll put an h here. I have 3 g's and 2 g's, that's 3. I have 1h and 4h, that's 4 for the greater amount. And that is my least common multiple. Start with the coefficients and then look at your variables. Now, if one of the terms has a variable and the other one doesn't, like let's say one has an x and the other one doesn't, then x will be part of your least common multiple. All right, the least common denominator, sometimes we call that the LCD, the least common denominator of two or more fractions is essentially the least common multiple of the denominators. So I look at these two denominators here, I look to see what the least common multiple is for 6 and 9, well it's 18. That would be the least common denominator of these two fractions right there and right there. So what I'm going to do is use what I learned in the last section about equivalent fractions, and I'm going to rewrite each one of these pairs of fractions that I have here so that they are using the least common denominator and that they're equivalent, and then I'm going to compare them to see which fraction is greater. Well, it's going to be 18 here. Okay, 18 is the least common multiple of 6 and 9. Is the least common denominator of these two fractions. To make that into an 18, I would multiply it by 3. So to keep it equivalent, I multiply the numerator by 3. To turn a 9 into an 18, I would multiply it by 2. So I'll multiply the top by 2. And that would be a 14. Well, with the same denominator, it's easy to see which fraction is greater. It's the one with the bigger numerator. So in that case, that would be 15/18 or 5/6, my original answer, 5/6 there. All right, I'm going to do this again. Well, actually 3 more times here. An 8 and a 20, I'm thinking 40. I'd have to multiply that by 5 to turn that into a 40, so by 5, so 5 times the top, that would be 25. To turn that into a 40 by 2, so 2 times the top, that would be 26. 26 is greater than 25, so this is my greater fraction of the two. Once the denominators are the same, you compare the numerators. All right, a 4 and a 10, I'm thinking 20. Times 5 makes that a 20, so times the top by 5 is 15. 3 times 5. Times 2 gives me 20, so times the top by 2, that's 14. Well, 15 is greater than 14, so 15/20ths is greater than 14/20ths, and that's my answer right there is 3/4. And the last one that I have there, my least common denominator for 5/16 and 3/10 would be 80. I'd have to multiply this by 5, so I multiply the top by 5. That gives me 25. I'd have to multiply this by 8, so I'll multiply the top by 8. That would give me 24. It's not much bigger, but it's a little bit bigger, so this is my guy right here. 25/80 is greater than 24/80, so 5/16 is greater than 3/10. Now I'm going to order these last three numbers from least to greatest, and I'm going to do this in a way by using improper fractions. One of them already is an improper fraction, 23/10, so I'm going to rewrite both of these as improper fractions first. 8 times 2 is 16 plus 7 is 23/8. 6 times 2 is 12 plus 5 is 17/6, and this is already 23/10. Now I look at this and I say, well, what would be my least common multiple here? Well, least common multiple, least common denominator here of those three fractions, and I'm thinking it's going to be 120. It's 40 for these two, and this has a factor of 3, so I'm thinking 120. 120 here, 120 here, 120 here. Well, 15 times 8 is 120, so 15 types here. See, 15 times, that would be 345. Yikes. All right, this is times 20, so this is times 20. That would be 340. And let's see, times 12, so this one times 12, that would be 276. So going from least to greatest, this is the smallest here. Then this one, then this one. They're in exact opposite order, so I'll just change the order around. 23/10, 2 and 5/6, 2 and 7/8, and that is the order from least to greatest. Now, it's important that you're able to add and subtract fractions, and you may remember you can't add and subtract fractions unless they have common denominators. So finding the least common denominator is important for a lot of reasons, including comparing fractions, as you'll see in some of the later sections. But remember, like always, practice, practice, practice.